Hey you guys, this is Mr. Sal. This is the Unit 2B review with special angle relationships, triangles, the sums of the interior angles specifically, and also we looked at exterior angles, the Pythagorean Theorem, and also the converse of the Pythagorean Theorem. So thanks for watching. Don't forget to like, comment, and subscribe. The instructions for number 1, solve for the missing angles. I'm going to start with W. I see that W makes a 180 degree angle with 107 degrees. So W would be 180 degrees, the straight angle, subtract the one angle, 107 degrees, and we get 73 degrees for W. Now with angle W, I have two of the three interior angles of that triangle. So I can solve for this missing angle, x. So I'm going to take the 73 degrees I just solved for, add it to the 51, which is right here. And that gives me 124 degrees. Now, the sum of the three interior angles is 180 degrees. So I'm going to take that 124 and subtract it from 180. And that will tell me the measure of angle x, which appears to be 56 degrees. Next up, we can solve for angle z right here. I got three angles on this thing, which will add up to this straight angle at 180 degrees. So I've got two of the angles, that's 51. This is 90 degrees. So I can take 180 and subtract those two angles, minus the 90, minus 51 degrees, and I get 39 degrees. So Z equals 39 degrees. Finally, I've got this other right triangle, and one of the angles is 39 degrees, so if I'm going to solve for angle Y here, I'm going to take that 39 degree angle, add it to 90 degrees, which is 129 degrees. And then I'll have to subtract that 129 from 180. And it appears to be 51 degrees, which is angle Y. So I've got four answers, four angles that we had to solve for on that one. And that one's done. Two ways you could have solved this one. You can solve for this angle first and then solve for angle x if you'd like. Or you could use the remote interior angles. Let's do it both ways actually. So to find this green angle here, I'm going to take the 48 and add it to the 24 degrees to get 72 degrees. Now these are the three interior angles of this triangle, so I'm going to take 180 degrees and subtract that 72, which is 108 degrees. Now we can't get this confused. That's the interior angle of the triangle at 108 degrees. So if I wanted to solve for the red one, these two angles, the red and green one, make up a straight angle, which is 180 degrees. But I know one of the angles, so to solve for the other one, I'm going to subtract it from the 180 to get 72 degrees. So x is 72 degrees. Some of you guys know that if we use the two remote interior angles, we could have stopped at this step and got the 72 degrees as well. Either way works. Number 3, if L1 or line 1 and line 2 are parallel, list all angles that are equal. Take 1 minute and do that with your partner. One said that are angles that are equal. Alright, angle 1 is equal to angle 3. I should write that bigger. And then angle 5 and angle 7. Alright, 1 and 3, what's their relationship? These are through the vertex. So these are called vertical angles. Same with 5 and 7. But let's look at angles 3 and 5 as well. What's the relationship between angles 3 and 5?
They're corresponding
Now these two are interior, and they're at different intersections on opposite sides of the transversal. So they're alternate interior, which means that since line 1 is parallel to line 2, they're also equal. If 1 is equal to 3, and 3 is equal to 5, and 5 is equal to 7, then 1 also is equal to 7, 1 is equal to 5, and so forth, okay? So this is the full list that we want. If you were missing that equal sign between the 3 and the 5 like this, you would lose points on the test. Now this isn't the only set that we have. There's another set. Now we could look at stuff you guys talked about in 7th grade, like angles 2 and 4. We know they're equal because all vertical angles are equal. But 4 is alternate interior with angle 6, so they're equal because the two lines, line 1 and line 2, are parallel. And also angle 2 is equal to angle 8 because they're alternate exterior angles. So these are the two sets that we were looking for on the test. We need all 8 angles in 2 sets of 4. Use the figure below to answer 4, 5, and 6. Number 4, name 2 sets of corresponding angles. Alright, that's very good. Angles 1 and angle 5, these are corresponding angles. And then you said angles 3 and angle 7 as well, right?
Yeah.
Yep, so those are other corresponding angles. There were 2 other sets you could put on this, such as angles 2 and angle 6, and also angle 4 and angle 8. Any one of these, or 2 of these 4 sets, would work as corresponding angles. Number 5, name 2 sets of alternate interior angles. So we know the interior is on the inside of these 2 parallel, well, they didn't say they were parallel, but these 2 lines. Angle 4 and angle 5 are not only interior, but since they're at different intersections on opposite sides of the transversal, they are alternate interior angles. So that was angle 4 and angle 5. The other set would be angle 3 and angle 6 are another set of alternate interior angles. Very good. Number 6, name 2 sets of alternate exterior angles. So these got to be on the outside of those 2 lines. It's very good. Angle 7 and angle 2 are alternate exterior angles. They're at different intersections on opposite sides of the transversal. That is correct. Also angle 8 and angle 1 are also alternate exterior angles. Alternate interior angles and alternate exterior angles only have 2 pairs. So this would be the only 2 sets for numbers 5 and 6 that we could use. On the test, if you have those switched as angles 5 and angle 4, that's fine. The order of them doesn't matter as long as they're paired this way. Solve for angle RAD. Take 1 minute to do that with your partner. Angle RAD, there's 2 ways to do this one. Some of you guys solved for this interior angle first. Others of you did the remote interior angles to solve for it, and that's fine. Let's do it that way, so I'm not going to worry about that interior angle. I know that this purple angle has to equal these 2 interior angles added together. So I'm just going to add them 130 degrees plus 37 degrees. And I got 167 degrees for angle RAD. Line L is parallel to line M. Name and determine the measure of all the missing angles. 1 minute, go. Alright, this angle at 85 degrees, which was given to us, that is angle BGH. And part of this problem said to name these also. So if you forgot to name these, make sure you do it. Otherwise, on the test, you're going to get those wrong as well. Now this angle, BGH, it is corresponding with this angle, angle CHD, which means they are equal because the two lines are parallel, so that also would be 85 degrees. So that's this angle. Also, angle BGH is alternate interior with this angle, which is, I'm going to call angle GHE, which also then would be 85 degrees. Now, since this is 85 degrees, and angle CHD is 85 degrees, if I look at angle CHD, it's alternate exterior with angle AGF, so it also would be 85 degrees. So we've got these named, and we've got them, the measures of these. But there's four other angles we need to solve for. So I'm going to solve for angle AGB, which is this one. And to solve for that one, I see it's a straight angle here. So I'm going to take 180 degrees and subtract the 85 degrees. And I see that it's 95 degrees. Now, since it's 95 degrees, it's alternate exterior angle. Angle EHD also would be 95 degrees. And its corresponding angle, this one right here, angle GHC, would be 95 degrees. And then finally, we got this angle here, angle FGH. Since it's vertical with angle AGB, it also would be 95 degrees. And there we go. We got 7 angles, including the one that was given, all 8 angles. We have all of them, all the missing angles and their names. So the first thing I notice on this one, solve for all the missing angles if line S is parallel to line T. So since these two are parallel, I know my angle relationships, alternate interior angles, alternate exterior angles, and corresponding angles are equal. So if I see this angle, which is 110 degrees, it corresponds with angle 2, so that also has to be 110 degrees. Alright, so let's solve for some of these other angles then, such as angle 1. This one right here. So that's a straight angle with angle 2. So I'm going to take 180 degrees and subtract the 110, which gives me 70 degrees. So angle 1 is 70 degrees. Now if angle 1 is 70 degrees, it is alternate interior with angle 5. So it's also 70 degrees because line S is parallel to line T. And it corresponds with angle 8, which means it is also 70 degrees. And angle 5 corresponds with angle 3, which means it also is 70 degrees. So I've got 3 other angles I can solve for here. If I look at angle 7 has these two not alternate interiors. These are remote interior angles, angle 5 and the 62 degrees. So I'm going to take my 62 degrees, add 70 degrees, and I got 132 degrees. Now we can solve for angle 6. And since I know angle 7 is 132 degrees and this is a straight angle, I can take 180 and subtract the 132, and I get 48 degrees. So angle 6 is 48 degrees. Finally, I got angle 4. Angle 4 and 6 are alternate interior, so it also is going to be 48 degrees. So let's look at these as a list. So there's the list there on the right of all of them. It's very nice. This one's asking us something a little different. It's saying find x plus y plus z. So not only do you have to find those angles, you have to add them together after you find them. 1 minute, go. So let's solve first for this missing interior angle right here. So to do that, I'm going to take the 55 degrees and add it to the other interior angle of the triangle, which is 65 degrees. And then I get 120 degrees. So if I want this angle in purple here, I'm going to take the 180 degrees from all three angles and subtract the 2 at 120, and I got 60 degrees. So this is a 60 degree angle. Now if I wanted to solve for angle Z, I can see that's a straight angle. So I'm just going to take 180, that's the straight angle, and subtract the one angle at 60 degrees, and I get 120 degrees. Now again, some of you guys noticed from the remote interior angles that it was right here as well. In any case, doesn't matter which way you use, as long as you get this answer, Z is 120 degrees. Next up, I'm going to solve for angle X here. Alright, so I got that 65 degrees. This is a straight angle still. So I got 180 degrees minus the 65 degrees. And then I get 115 degrees. So that's my X angle. Next up, I've got this other straight angle. And I know the 55 degrees, which is going to help me figure out the Y angle. Since it's a straight angle, I know it's 180 degrees. Subtract the 55 degrees. And I got 125 degrees. Now that's Y. But these three actually aren't the answer we want because it told us to add the three together. So my X angle, which is 115 degrees, my Y angle is 125 degrees, and my Z angle, which is 120 degrees. I'm going to add these together, and this will be my actual answer at 360 degrees. On number 11, you could solve for this interior angle here, which can help us to solve for F. Or you can use remote interior angles, it's not going to matter. And this is a straight angle with the 64 degrees, so I can take 180 and subtract 64, and then I get 116 degrees, so that's this angle. Now those three angles add up to 180, the 116, 21, and F. So if I take 116 and add it to 21, then I get 137 degrees. Now these three angles add up to 180 on the interior of the triangle. So if I'm solving for angle F, I've got to subtract the other two, which add up to 137. And it looks like it's 43 degrees. Solve for angle 1. Line M and N are parallel, which is important to know. Since this is 75 degrees, then its corresponding angle here would also be 75 degrees. And then all I'm doing is looking at this triangle by itself. So you could draw it aside if you wanted to. This is 34 degrees. This is 75 degrees. These two angles. So if I wanted to solve for this angle, I would add the 75 and the 34, and I get 109 degrees. I'm just going to take that 190 degrees and subtract it from 180, and it looks like it is 71 degrees. This angle 1, 71 degrees. Number 13, determine if the triangle makes a right triangle. So we first need to identify, it looks like 8 and 15 would have to be legs because they're the shortest sides. 17 is the longest, so we would have to assume that's the hypotenuse. So I've got the two legs, 8 and 15. If I square those and then add the squares together, it should give us the hypotenuse squared as well. So let's just evaluate these. 8 to the power of 2 is 64. 15 to the power of 2 is 225. And 17 to the power of 2 is 289. So when I add these together, again, we're seeing if it's equal. If it's not equal, then it's not a right triangle. But as it turns out, so let's combine these two together. 64 plus 225 is 289, which does equal 289. Since this is true, determine if the triangle makes a right triangle. So yes, it is a right triangle. Uh, 14. In the Pythagorean Theorem, the square of the hypotenuse is equal to the sum of the squares of the legs. Alright, what is the length of the missing leg? So we'll use the Pythagorean Theorem on this one. So we'd have a leg squared plus the other leg squared should equal the hypotenuse squared. So the legs are the sides that make up the right angle, so I've got this one at 4.5. So I'm going to replace the A with 4.5. And then I've got this other leg here, which is shown as the X, and that's what we'll solve for. And then we've got the hypotenuse, which is opposite to the right angle, at 7.5. So next I'm just going to square 4.5 and 7.5. So this is my new equation. Next, what I'm going to do to solve this thing is subtract 20.25 from both sides of the equation. And we're going to get x squared equals 36. So if I had made this a square, that would be the area. I don't want the area, what I want is the length, so I've got to take that area and square root it. If I put that in the calculator, it gives me x equals 6. Now if this had units, I would label that, but for now that's going to work. So in my calculator, when I put 4.5 squared plus 6 squared, I should get 7.5 squared, and it does, it checks off. Ray is a contractor that needs to access his client's roof in order to assess where the roof needs to be replaced, or whether the roof needs to be replaced. He sees that he can access a portion of the roof that is 15 feet from the ground. He has a ladder that is 20 feet long. How far from the base of the house should Ray place the ladder so that it just hits the top of the roof? We'll round our answer to the nearest tenth of a foot. So what I'm going to do on this one is draw a picture. So this line is going to represent the house. And then of course he's leaning the ladder up against the house. There's our ladder. And then we want to know how far away from the house the ladder is set on the ground. Just so that it hits the top of the roof. So this is what our picture looks like. And we don't know this value. However, that red length right there would be a leg of a right triangle, right here. And we know the portion of the roof that is 15 feet from the ground, so this distance here is 15 feet. It said the ladder is 20 feet, so we need to figure out how far away the ladder is set on the ground from the house. Okay, to solve this one, the ladder is the hypotenuse, and then I've got a leg at 15 feet, and then another leg at x feet, which we don't know yet. Alright, this is the Pythagorean Theorem, so I've got the two legs that are squared added together, which would give me the hypotenuse squared. So to solve this one, let's evaluate 15 squared, which is 225, and 20 squared is 400. Now to evaluate this, we're going to subtract 225 from both sides of this equation. And then that gives us x squared equals 175. Now that would be the area if I were to make a square down here from this. That would be the area of that square. I do not want the area, I want the length, which means I'm going to take the area at 175 and square root it. That's not a perfect square, so it won't simplify in the calculator. So for now, since we haven't learned how to simplify these radicals like this length is the square root of 175. Don't forget to label it, though, in feet. If AD is 7.4 feet, DB is 5 feet, BC is 6 feet, calculate the length of AC and CD to the nearest tenth of a foot. So it says right off the bat that AD is 7.4 feet, so we'll write that in, 7.4 feet. DB is 5 feet. And BC here is 6 feet. So what we want is the value of CD and also AC. So I have to solve these one at a time. I'm going to take this triangle here, CDB, and just write it out here separately. CDB. This is 90 degrees here, which they probably should have told us. That's okay. 6 feet and 5 feet on this. So I'm solving for a leg on this one right here. Length CD. So I'm going to take my hypotenuse as a square, and this area is 36 square feet, and then this area is 5 times 5, which is 25 square feet. So when I want to solve for this square's area, I take the area of the hypotenuse square and subtract the area of the leg square, and it looks like that's 11. So CD, the length, would be the area of that square 11, but square rooted. And of course, don't forget to label in feet. So there's one of our answers. Oh, it did say it around to the nearest tenth of a foot, so let's fix that. Square root of 11. So as a decimal, rounded to the nearest tenth, 3.3 feet. All right, let's do CD then. I'm sorry, AC. All right, so I'm going to take this triangle and I'm going to move it over here as well. Let's label it. And the length we want on this one is the hypotenuse, which is opposite the right angle. And we already know the length of AD was 7.4 feet. And right now we have the length of CD, which is at 3.3 feet. So, once again, if we square these, so if this is a square, its area, 7.4 times 7.4. So that area would be 54.76. And we got the area of this square, 3.3 times 3.3. But what I really want is the area of this square, this area, and it would be the 54, because that's the hypotenuse, 54.76 plus the 10.89. So yeah, for me, adding these two together, I got 65.65. Now that's just the area. The length of AC, the length of AC is going to be that area, 65.65, but square rooted, which in my calculator should give me a decimal right away. So the length of AC is 8.1. Don't forget to label that again in feet. Number 18, simplify using only positive exponents. So on this one, I'm going to use the rule, negative 11. And I've got exponents of 9 and negative 5. This one we're multiplying the bases, so we're going to add those exponents, which leaves me with negative 11 to the power of 4. That's my answer for that one. All right, number 19, it's the same base, the negative 8. Then we have the exponents of 7 and 4. 7 for the numerator, 4 the denominator. But this one is dividing the bases, so we're going to subtract the exponents, which gives us negative 8 to the power of 3. So let's see why we subtracted on this one. So in the numerator for this one, I'd have negative 8, but I would have it multiplied by itself 7 times. And then in the denominator, I've got 4 of these negative 8s. And what happens is anything divided by itself is 1, so that's 1, 1, 1, and 1. However, those become phantom ones, and what we're left with is just these 3. So by canceling those out as phantom ones, it's like subtracting. It's taking the number of negative 8's in the numerator and subtracting the number of negative 8's in the denominator. And this one would come out as negative 8 in parentheses to the power of 3. All right, number 20. This is a 90-degree counterclockwise rotation around the origin. The origin is right here. And I've got this shape with these corners. This triangle with these corners here. And so I can trace it if I were to use a scratch piece of paper. And I'm going to rotate it 90 degrees in the counterclockwise direction. So let's go ahead and do that. All right, so 90-degree rotation would be something like this one. And so we can put those points on there. All right, so there it is, 90-degree rotation around that origin. And yeah, that's the answer right there. That's what we would want to see on the test. Some of you guys noticed also, like if I took this point here, I can connect it with the center of rotation, and then I've got a 90-degree rotation in this direction, which would give me that point. Draw the line of reflection. All right, so I just need to take two sets of points. Let's take D and D prime. If I connect those with a straight line, then the line of reflection will be halfway between those, so it should go through this large purple point here. I can do the same thing with B and B prime. You could use C and C prime or A and A prime, but I'm just choosing these two. And then the halfway point between these two would be right here, which means that the line of reflection has to go through those 2 points, which would put it right there. So that blue line right there is the line of reflection. All right, in the beginning it says if angle 1 is 40 degrees and line M is parallel to line N, find the measure of all the other angles. Well, that means that angle 1 is 40 degrees, which we do need to know. Now if line M and N are parallel, which it says they are, then we know that the angle relationships, special angle relationships, are equal. So for example, angle 3, which is corresponding with angle 1, we'll even write that out here, angle 3, would also be 40 degrees. All right then. Also, angle 6 is alternate exterior with angle 1, so it also would be 40 degrees. And this should help me find pretty much all these other angles. Angle 9 is vertical with angle 1 because it's through the vertex. So angle 9 would also be 40 degrees. But then I've got angle 10 right here, which is straight angle with angle 1. So that would be 180 degrees minus the 40 degree angle from angle 1. And angle 10 is 140 degrees. All right then, angle 2 is vertical with angle 10. So I have angle 2, which would also be 140 degrees. All right, I've also got this triangle here in the middle, and I've got two of the angles. In fact, I'll draw it up here so we can see it. This angle shows as 90 degrees, and we've already figured out this one's 40 degrees. So I'm going to solve. Oh, it didn't ask us to solve for this one. Okay. Well, all right, we didn't need that. Let's solve for angle 7 then. So if angle 3 is 40 degrees, and angle 8, this is 90 degrees, then angle 7 would be 180 degrees, minus the 40 degree angle, minus the 70 degree angle, and this would also be 70 degrees.
How are you closer to me when I didn't even...
I'm sorry, that's a 90 degree angle right there, angle 8. So let's change that. That's a 50-degree angle there. Alright, we got a couple angles to figure out still, but these ones are nice. Angle 8 is 90 degrees. We'll just list it as 90 degrees right here. Angle 5 is vertical with angle 8, so it also would be 90 degrees. Then it looks like all we've got left is angle 4, which is vertical with angle 7, so it also would be 50 degrees. And it looks like we got all of them that they asked for. If you were curious about that triangle, it's alternate interior with angle 7, so it also would be 50 degrees. But it didn't ask us to do that one, so you didn't have to. So hopefully you guys noticed most of the work on this one was just knowing the relationships between the angles as alternate interior, alternate exterior, or corresponding, or straight or vertical angles. We could have used the angle sum of a triangle, but it wasn't even necessary that we do that. Number 23, name all of the corresponding angles, alternate interior angles, and alternate exterior angles. Alright, we'll just do this in list format. So corresponding angles would be something like angle 1 and angle 3. And also angle 5 and angle 7 would be a set. And then also angles 2 and angle 4, and then finally angle 6 and angle 8. Alternate interior angles have to be on the interior of the two lines on the transversal at different intersections but opposite sides of the transversal. So interior, I'm looking at angles 2 and angle 7. And then also angle 6 and angle 3. Next up, alternate exterior angles have to be on the exterior, but they have to be, since they're alternating, they have to be at different intersections on opposite sides of the transversal. So I've got angle 1 and angle 8, and then also angle 5 and angle 4. Find the missing side length. Well, let's identify which side length it is first. This one is the hypotenuse, because it is opposite to that right angle. So I know 6 is the leg, right here. And then 2 would also be a leg. And if I square those, then add them, then I would get the hypotenuse as a square as well. So 6 to the power of 2 is 36. And 2 to the power of 2 is 4. Added together should be c squared. So when I combine these two together, I get 40. Now equals the hypotenuse as a square. But we don't want the area of that square. We want the length. So we're going to take that area, 40, and square root it. This is the answer we want. Do not write the decimal unless it asks you to round it, or unless the calculator gives you a terminating decimal or a whole value. So, we found the missing side length. What is the perimeter of the following triangle? Well, we see 2 of the side lengths, which are legs. This one's a leg at 3, and the 4 is a leg also. So, if I add those together, I would still need the hypotenuse, a c value, in order to get the perimeter. But I need that c value first, so I need to solve for it by taking my 2 legs, 3 and 4, and I need to square those and then add them together to get the hypotenuse as a square. So evaluating these, well, 9 plus 16 is 25, and that equals the hypotenuse as a square. But we just want the hypotenuse, so we got to take that area, 25, and square root it, and we get the value of 5. So I know my C value now is 5. And when I add these together, I get a total of 12. So the actual perimeter on this thing is 12.